Evening, everybody. So here we are, lesson 7, the last final lesson. Next week, we'll go do a gigantic review and then dive into the final. Then August 8th, that's it, end of term, coming close. This week kind of puts everything together. So up till now, we learned the basics of Python, a lot of functions, difference between um, methods and functions, loops, um, comparison operators, if-else statements. It's the basics, it's fundamentals. It really is. And you're going to see them in every code, every piece of code you ever see now. These things are always there. They're the fundamentals for a reason, right? Because they work and they're just part of the fundamental logic. But working with files is kind of cool because in this lesson, we open a file, we generate a new file, but that's just the start of it. When you start writing your own scripts to collect system data or user data or metadata about something or query a database, you you store it in a variable, but then you have to put it somewhere for long term, either in a file, a database, or something like that. But Python could do all that. It allows you this construct to where you could create new data out of thin air. You could extrapolate metadata from different objects, create a new object, and then output it to a file and keep it indefinitely digitally. That is super cool. Now, the whole concept with files, there's a couple different styles of people who work in IT, right? You have your user base who uses data and creates data. You have your administrators who manage systems, and they're users too. They create data and manage data too. You have your database analysts who are users as well as managing gigantic data infrastructures, network admins that allow people to get to data, right? The transport layers and so on and so forth, network and transport layer. So you're going to find yourself in IT working somewhere in one or many of these layers. So they all use data though. They really do. Like literally infrastructure as code in cloud environments using Ansible or Terraform or something like that. Like it's files, coded files that are pushed out to generate and create a digital infrastructure. Like it all comes down to this thing of a data type and some type of file. Now, I'm oversimplifying this, but let's, I guess let's do it, right? We'll just do it. So I'm going to go ahead and just hit Windows R, type in Notepad and hit enter. And I'll pull over Notepad to the screen. And this is how a lot of folks interact with just simple text files, right? They open up Notepad, they go file open, control O, right? They'll go somewhere, they'll find something, and we'll just do, I don't know, we'll do lesson 7, see if I have we'll just do, I'll just Romeo and Juliet full. Now I'm going to click open. Open does more than open. It interprets what's in the file, sends it to the program to standard output, and then displays it to the user. That's open. Open works a little different in Python. You could open a file without displaying it anywhere, making the data available to other code, other services, processes, systems. You always don't have to see a file when it's open. When you access a database, you send a query to it and it gives you data back, but you don't see all the data. You just receive back the data that meets your query. It's kind of similar to a file, but a file is an object type. Python is objective. There's certain things you can do and can't do to a file type object. So at first it feels kind of odd if you haven't worked with a file via command line or script before. But eventually you're going to realize that this is the way you're always going to use it. Like you stop becoming dependent on PDFs or Word docs or Excel documents or there's still use cases for them, but you start using data differently within code. You always don't have to see it. You can still see if it's there, get content, concatenate, grep, things like that. But when you start working with a file from the command line, strange things happen. You realize that you can create more data, collect more data, and create files at a faster rate. And then once you create that file or multiple files, you can ingest them somewhere, open them all up, pull in all the data, look for certain things, generate fun graphics using all kinds of matplotlib and stuff in Python. It's just this scale that it opens up to you all of a sudden. So you're not bound to opening up one or two documents at a time, sharing a screen. And we're going to check that out, right? But any questions so far? Just on my little rant of file object, stuff like that. And we're going to parse the screen up here in a kind of a usable format, but I'm also cool. Nope. I'm also going to show a directory structure of where we're going to be living today. So let's just go to this location. I'm just going to go to this location over here. Lesson 7. So this guy, right? We're going to come back to this directory structure in a second. So you notice that in the idle over here, we have the absolute path. C user, Z Whiten, OneDrive documents, 2252 Spring 2025. Yeah, it's an old folder, but who cares, right? And if I open that directory in Windows, you'll see that I say open words.txt. And we'll see that words.txt is in here and it's 1.1 meg, right? Well, let's go ahead and comment this out. Been working a different programming language all day, and there we go. So I'm going to save this, hit F5, we're going to let it rip. So we open words.txt, and since I didn't give it an absolute path, it looks in the path that my script's in, which words.txt is in there. We say file in, open words text, print file in. It prints that it's an object type of text input output wrapper, IO wrapper. Its name is words.txt and its mode is an R, default for read mode. We'll talk about encoding later. And then I just say print stuff, 1, 2, 3, no big deal. Get the length of stuff is 3 because I have 3 objects ready, 1, 2, 3. And then I can do the length of fin, the file in, and it breaks. It says the text input output wrapper has no length. You're right, because file in right now only holds an open file. Didn't read it. It literally just, it's like taking a book and open it up anywhere, but not reading the pages. It's open, it's available for you to read, but you didn't read it yet. That's what open does. Kind of cool, right? It's good practice. Every time you open something, you close it. We'll talk about that later. So any questions about open so far? It makes the content available to you if you have the proper permissions and all that fun stuff. Cool. I gotcha. So here we're going to open it again. I'm going to set a counter to 0, and I'm going to say for each line in my file in, add 1 to the counter, print the count. Boom. So before I could even find Notepad and go to Control O, open, find my path, click on my file to open it, I literally just say open, count the lines, show me. And what it does with this open object is it reads each line top to bottom when you rip it through a for loop. And when it finds a hard return at the end, it adds 1 to the counter. It goes down each line. So there's 1,000 or 113,809 lines in this file, which is 1.1 meg, which is every word in a dictionary. Not the definition, not the pronunciation, not the etymology. It is just the word, right? 1 word per line. So that's kind of cool, right? We opened it, we ripped through it, we said, cool, this is cool. Well, now we're going to read line. Read line is a method. So if we go over here and we say type of fin, we see that it's still an input-output text wrapper. Cool. So it's an object type that allows you to access a file type. Different files, here we're using just a plain text file, TXT file. Different files sometimes need different methods, but that's a little bit more advanced. When you start to get into complex file objects like JSON or XML, or mostly JSON nowadays, or YAML, but Python has modules that allows you to work with those objects as well. Let's just focus on this text file. We say, open that file, read the line, read line, read line, read line. We'll see what this does. You guessed it. It remembers the line that it read. It reads the first line, AA, finds the hard return, stops, reads the next line. It caches where it left off. So every time you say read line, it gives you the next line from where you left off. Helpful. If you want to check if a file, if you know for a fact every time you query a database and export a CSV, it has the headers in the first line, you could just do open that file, read line, does read line have this in it, to make sure that the header or the column name you're looking for is in the first line. This is helpful. At first, it seems like it's not helpful until you need it, right? And I gave you a scenario where you may have to check a header line for something. You could use grep and stuff too, but let's just talk pure Python, right? So kind of cool. Read line. It's a object method, or it's a file type object method that allows you to read a line. And now we're just going to say file in read line, throw that line, the first line into a variable, strip it, and then print it. Oh, what happened? Did you mean bin? Fin. Fin is not readable, right? So let me do this again. There we go. So you notice when we read the first line, it had a hard return. And then when we stripped it, it removed that and we got no space. Helpful. Let's do that in mass now. We're going to open the file for each line and line, strip it, and print the word. So now I'm going to Control C and break this. If it does break. Stop it, break it, break, 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 break. Why would it break? Anybody know? I want to break.
I'm actually
Oh no,
curious
what
why it
happened?
won't break.
Say again?
I'm actually curious why it won't break.
Yeah. So that's just memory already cached. It caught that I hit Control C, but it had to catch up with the cache in order to execute it. That's it. So it caught it, it broke it, it got the keyboard interrupt down in the traceback. But you see how much it cached before it stopped? It didn't just stop at the next line. It's quick. Python's fast, right? Faster systems, you get more stuff in your cache. But you see it counted a ton of words. It removed those spaces, a little cleaner to read. I would never do this, especially out to a screen. Um, this is just a 1.1 meg file, and it has 113,000 lines in it. What happens when you have a 10 meg file or a gig file? They get crazy big, crazy long, right? Log files are notorious for being certain syslog, XML type variants. They're insane. They're insanely long. So putting it out to the screen is not always a wise choice. But you could read line, individual line. You could read lines and give it a number, which we're going to walk into right now. So here, we're going to open words 2. Words 2 is in our little folder here. You'll see that it's only 1 kilobyte, but there's not the whole dictionary in there. It's not 1.1 meg. It's just same couple first words. We're going to work with that. So we're going to open this file. We're going to call on the file in. We're going to call the method of read lines. So it'll read the complete file. This is tricky. If you're working with large files that are, say, over 100 meg, You don't want to keep opening them because you're going to fill up your memory and crash your system. You sure don't want to try to open a file that's gigs and gigs or terabytes in size. It'll never open or take a long time, and then it'll be sluggish to work with it. Kind of like how large language models work. You don't want the whole model to exist in your memory because you don't have infinite memory. So read lines is helpful if you're dealing with smaller file types. And I'd say under 100 meg is pretty substantial common. So we're going to use read lines, store that read data into a variable called words2. We're going to print it. Now, what we get back in our object of words2 is you get a list of each line, and each line is followed by a hard return, a hard return. But this isn't a problem because last lesson we learned how to work with lists. So now we could do everything we learned last lesson, we could do now from a read lines object. So now we open this file, use read lines, store the data in words2. Now we get the length of words2, and it says that there's 15, 0 through 14 indices. There's 15 objects in our list or lines. And then we could call on our index of 13, which is AAS, which is index 13. This is index 14. This is index 0. Here's our 13. So everything we learned last lesson is applicable after we leverage read lines. Cool. You can do all kinds of fun stuff with this too, by the way. So let's take a look at this joker right here. So here we're going to open words2. We know that there's 15 lines, 15 words. Now we're going to use read, and we're going to print the length of words, and then we're going to use a slice of 3 through 20. So when we say length of words, we get 98. Read creates a different type of object. It creates, here, I'll do this over here. I'll do print, what do we call it? Print words. And you get all of the words in a new line, or all the characters in each other new line. But when you use length of words, it counts each character to include the hard return. And then when you start slicing and say start at 3 end at 20, you get this aha thing. Well, let's count this. Start at 3. 0, 1, 2, 3. Then stop at 20. Well, 20 is right here. Kind of cool. Helpful if you know the type of data you're looking for, or you have an idea of where you're looking in your data object. So we covered open, read line, read lines, and then read. Read reads the entire object into a variable. Similar to read lines, except it removes the hard returns. So it's more just like text, flat raw text. Sometimes you want that, sometimes you don't. The difficulty with read, once again, is if you read an insanely large file, it stores it in memory if you throw it in a variable. There are techniques to not do that. They're more intermediate Python, but there are ways to read. Say if you have a 600 meg file and you don't want to read it all in memory, you could throttle how you read a file and read it 10 megs at a time and dump it from memory every time you read it. There are those techniques. A little bit out of scope for this lesson. I just want to bring them to your attention that it's possible. So you got open, read line, read lines, and read. Cool. Now you're starting to see the difference about how things like Word and Notepad do all this easy stuff for you. They make it easy for a user to manipulate data, but they really manipulate data in an object that's displayed to them in another program. A little complex, but it's how the way the world works, right? What do you think so far?
Looks
It's
good
fun.
so far.
Yeah, it's fun stuff. So there's more methods. Everything we used in string land, all the methods, once we read it in a file and we have it, it's raw text or Unicode representation of text, we could rip through it and start with from. So we have this mbox text file. This joker right here, mbox text, is 6.6 meg. If 1.1 meg was 113,000 lines long, can we guess that this is 6 times larger? Yeah, it's a fair assumption. So this thing is insanely long, right? Massive. It's only 6.6 megs, but there's a lot in there, is my point, right? So we're going to open the air. I'll just open this file. What this is it's a exchange server log. I think it's let me take a look. I'll be able to tell if it's exchange or something else. Yeah, it's just a mail server log. So you got all your froms, return pass, receives, all this fun stuff. And now this will also make you worried if you're not like cybersecurity aware or understand that, oh, every email, every text message I save is logged. Yes, it is. Time stamped, everything, right? So this thing is massive, right? It just keeps going forever. Insanely line. It's 132,000 lines, but there's more text in each line. There's more objects in each line, right? Characters. So we're going to go ahead and open this. And we're going to say for each line in my file in, if the line starts with from, print the line. Oh, there we go again. I broke it. So now it's displaying just the from lines. Cool, helpful, real scenario. It's a bit weird to me, but I'm trying to wrap my head around it probably in my head. Yeah, yeah. Once you start working with files and do exactly what I did, open up Notepad, open up a file, think about the steps you're doing and think about how Notepad, the program, is performing that task for you. And then close that and then move into Python, then work with a file. You're doing it, but on a lower level. Same thing that program does for you, except you're working with it on a lower level. And right now we're just opening files and looking at the data. Pretty soon we're going to be manipulating them. It's going to be cool, right? So we're using the starts with method, which is for strings. So now everything we learned in lesson 5 is good for some data inside most of our text files. So we have lists from lesson 6, lesson 5, fors, ifs, all this stuff. So now we're starting to combine everything we learned through course up till now to work with file types, file data. Super cool. So now we're going to toss in strip here. Same thing for each line strip starts with from, and we're going to get rid of these pesky spaces. There we go, right? And now we can even output this to another file if we wanted to, which we'll get to. So now we're cleaning it up a little bit. It's called normalizing data, pretty common in the data science world, right? And now we're going to open that file again. We're going to strip it. Now I'm going to say if not line starts with from, continue, else print a line. So it's a reverse logic of doing exactly what we have been doing. But the logic was just changed. In saying if line starts with, I used an if not from. Knots, sometimes knots could be programmatically expensive. It really depends. You got to understand your data that you're working with. This is just an example of doing one directly. If line starts with and if not, no big deal, right? Just showing you some operations and some things you could do with your data. Same, right? So here, let's check this out. So here we're doing this again. Open the file for each line in my file, strip it. If line find, here comes the find method. We're looking for a pattern. The pattern we're looking for is at uct at ac.za. We're looking for a domain, right? And now we're saying is equal to 1. Remember what happens when you find, right? So equal to 1 is what? If it found it. Or is it the reverse? What do you think? By looking at the output from this, here's the pattern. That's not the pattern. It's not the pattern. Why is it giving me mixed emotions here, mixed things? Anyone know? What if I do -1? -1. -1 is true, right? So now we're saying every time you find is equal to -1, continue. So if you didn't find it, print a line. Or if you didn't equal -1. So this comes with practice and how you use find, right? Just get used to using find because it is your best friend. Find rips. And the more you get used to using it, the more it makes sense, the faster it is to find something. Now, could you use in too? Just say, is Bob in my rule or list? Yeah, you could do that. Very similar. But what I want to show you is that things that you learn in different lessons, now that you read in text strings from a file, everything you learned about how to manipulate strings still works. Yep, exactly. You could do that too. Yeah, I'm reading the chat, by the way. Yep, it's all about how you want to work the logic and what you're looking for. Super cool stuff. Let's see what else we got. We got this guy over here. Boop, boop, boop. So now you can even add more to it, right? You could say F5 this. You could say enter the file name. Well, it's running from the same location. So I could literally just type the name of the file, which is mbox text, right? .txt. I hit enter. Boom. Look how fast. I didn't have to open up Notepad. I didn't have to control O. I didn't have to find my directory. I didn't have to double click and click open my file. I literally said, enter the file name, mbox text, have some logic written to count each line, look for if the message starts with message ID. Now I could say that there was 1,797 messages that were sent in this log. Super fast, super nimble, super helpful. This is combining all the skills we've learned. For, ifs, working with strings. It's kind of cool. Super cool stuff. How's everybody feel so far with working with open and things like that?
I think it's easy enough.
Yeah. And it's just like everything else. The more you work with it, the better it gets, right? And the simpler, the more it makes sense. Now this is going to be fun. So now that we learned how to open a bunch of files, which you should always close your file, or you could use with. We'll talk about with later. With is the newer way of doing it, right? Now, got a couple notes up here, right? If the file already exists, opening it in write mode clears out the old data and starts fresh. Read allows you to access the data that was already there. Write mode basically deletes all, keeps the file object, but removes the context that's in the file. Not cool. And if it doesn't exist, it creates a new one. So if you say open timmy.txt and it doesn't exist, it'll create timmy.txt. It's kind of like doing a touch in Linux. If that makes sense. And we're going to prove this right now, right? So I'm going to say open class output 76 txt in write mode. And we're going to see I'm working in this directory still. And we're going to see that there's no class output, right? Now I'm going to leave this open. Now, this is going to be the fun part, right? So I'll leave this here. Let me shrink this guy up if I can grab it right. Come on, sucker. Let's do this. And we're going to rip this, and you're going to see the code run and create the file, right? Now, just follow me on this. We're going to open this file. It's going to create it. We're going to throw some text in a variable. Then we're going to call in the write method, then our variable, another definition write method, and then we're going to close the file. Watch this area down here. You're going to see a class output 76 be created. Should be right underneath captions. And it took a while to show up, but you notice that this existed super quick. And it took a while for the screen to catch up and display that the new file was created. But it was there for about a half second before it was displayed because the computer has to understand what to display. The operating system displays that to us, but the file was already there. So just be aware of that. But now we created this new file. It's 1 kilobyte. And if I double click and open it, if I actually click on it and open it, you'll see that here's our variables written to the file in order. Write line, close. So now we just learned a new method for file types called write. Open, if the file doesn't exist, it will create it. Write line will write exactly what argument you pass it, and then we close the file. It's best practice to close your file. If you leave a file open and Python's still running and something has to write to that file, it can't because the file's locked. You ever work in an enterprise and share a file with someone on a shared drive or SharePoint or something and open up the file and then someone goes to use it, they contact you and go, "Hey, can you close the file? I need to update this." Same premise, permissions, simultaneous writes. The file becomes locked when a user has it open. This is why things like simultaneous working on files is amazing. Or does it break the permissions to allow you to both access it? Or is that by design? It's all three, but kind of neat. So that's kind of cool, right? Now we're learning how to create files, create data. I'm going to create a list. I'm going to throw some text with new lines, with a new line, and line one with new line two, line three. I'm going to create a new file called class output in write mode so I could use the write methods to it. And now I'm going to use the write lines method, different from write, and I'm going to give it my list, and I'm going to close the file. But yeah, we'll do that. We'll close it. We'll just do that. So you'll see here that class output 30 will be above class output 76, right? Save it, F5, it's done, it's there, it's 1 kilobyte, something's written to it. Now, instead of opening it, I'm going to open it Python. I'm going to say open my new file in read mode, print each line. For each line, print the line. And here's our output. Look at our list. Line one, new line. Line one, new line. Line two, line three. Line two, line three. There's no new line because there's no new line in my list. So now we created a new file, wrote multiple lines to it, opened it, validated that it is indeed updated. Super cool. Any questions so far? This is going to get fun, right? So now we're going to throw in the next method, and you guessed it, it's write line. But we're going to use a new type of mode for a file. We have read, we have W, we have R for read, W for write, and now we have A for append. We're going to open append.txt. Now it's created, it's here already. Let's just do this. Test, 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 save, F5. We'll put that there. We'll hit save again, and I'll close it. So append has test, 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 and a timestamp. We're going to open that file in Python in append mode. We're going to print the file. We're going to create a new string, and then we're going to write that string to that file, fout.write our line. Then we're going to close the file. Boom, it's done. I'm going to double click, open append again, and now look what happened. It was added to the end of the file. If I kept it open, it would have failed. It would have just sort of traced back because it was already open. Now, it depends if I open it in Python or left it open manually. So let's do that again, right? I'll leave this file open and I'll change this to 29, save F5. Now, you notice it didn't update my file because it was open, but Python didn't error out. If I go over here and view, edit, there's no refresh. A lot of text, um, a lot of simple text editors don't have a refresh, right? So I have to exit this and now open it again, and now it shows up. Now there's a trick to this. A, I'm the same person working on the same file. Okay. Same session, sort of. Two different processes running on the same file. You have Notepad process is the parent process of the document. Then you have Python being the parent process of the document. Not all operating systems or not all policies allow you to have two programs opening the same file. Just be aware of all that matters, right? So that's cool. Now, I had to close it in Notepad and then reopen it to see the change, though. Just be aware that when you work with files, understand the state of the file you're working with and the permissions, the underlying permissions to it, and also what mode you're in, read, write, or append, right? Now, I hope that helps because we're going to do more stuff, right? Now, we're going to open append, we're going to read lines, and I'm going to write, and I'm okay again, then I'm going to close it. Oh, what happened here? What was the problem? Open append.text.a, read lines. What happened? Unsupported operation, it's not readable. Why is that? Writing files.py, line 42. What do you think caused that? Read lines. Any idea? Save it again. Let's close everything. Make sure it's closed. I'll open it. We'll take a look at it. I don't see it. I'm okay. I'm going to close this. Hit F5, save. Let's go. Invalid syntax. Well, that's me making a mistake there. Same thing, not readable. Well, now we start to look at this and go, well, what's the problem here? Read lines. I append another line. I wanted to append it. I hit append mode. I went to read lines. I went to write it. I tried to close it. What's the problem? Well, did we close it to begin with? Yeah, we did. Let's double check this. We're going to close this session. I'm going to open up the Python shell again. Then we're going to rerun this just to see if this is a problem. Still not readable. Is it in the correct location? Yeah, it's in the correct location, right? Same, append. Why would it allow me to open it? Any ideas? What if I open it in read mode and I just said print F out? What do you think? Is that the problem? See, boom. So I could open it in read mode. This is me opening it. This is the print F out. No problem. Why didn't it like read lines? Any idea? Let's go back to other examples.
Wait, was it because you had a pen and a pen can add stuff, but it can't read, right?
Ah, there we go. Bingo.
I had to bring out my Python
Yeah.
book.
Yeah, that's exactly it. So it's the mode that we're in is causing the problem. So remember, and that whole rigmarole I just did was for you to understand what mode you're in. And that comes after open, your target file type, then your mode. Read to read, A to append. So your methods that you call on have to match the action and mode that you're in. It's Python saving you from yourself from doing something accidental, right? That's the big one. And that was a whole exercise of me showing you, oh man, the modes matter. They matter. Well, pretty cool stuff. But if you think about this, write is amazing. Write lines is awesome. So what can't you do? You could append, you could create a new file if it doesn't exist. You could do all kinds of fun stuff. It's you get to the point to where now you could, okay, I could really build things. And that's true. You can. Is this pickle? Yeah, this is fun. So trying to see. This is I do want to cover these because these are pretty important. But I'm going to show you. I'm not going to get in the pickle. I have a whole other video I'm going to give you on pickle. It's it's kind of I want you to master working with files before you worry what a pickle is. A pickle is a serialized like database, a deserialized database of memory. It's another data type that Python has. It's very helpful, honestly, when you have to send data back and forth over the network. It's not encrypted or encoded. It's just deserialized, and it's really hard to catch in transit. And the only way like hackers or man-in-the-middle attacks could, if they catch it, save it, and someone goes, "Oh, that's a pickle format," then they run a dpickle to get it. It's a little bit more complex, but I'll send you a link in the video to watch the whole pickle video. Now, the cool thing when you start working with files is you start thinking about like, man, I'm an admin. I need to do things with data. How can I check if files exist or what I'm in, right? So you could import this module called OS. And in OS, there's a lot of fun things. You could work with the operating system. You could make directories. It's a lot of very similar command line or terminal commands that Linux and Windows have, except you could do them through Python. So you never have to leave Python to do it. So it's kind of helpful, system administrative wise, right? So now that we have OS installed, you can say os dot get current working directory, open close parameters, hit enter. And this is the directory that I'm currently working out of. Super handy, right? And you could also get the absolute path of a file. So you could say os.path, absolute path, and you know this file's in there, you hit enter. It'll give you the absolute path to include the file name. Insanely handy methods, right? And this is from the OS module, the path function, the absolute path method, right? So the class of object and what you want to do. Super handy. Now, this is a huge one. This is exists. So now you can see if os.path exists, look for a file name. It looks in the default path that I'm in and gives you a true. Now, if we did that and I hit a mailbox, oh, my bad. We'll just do again, my bad. It's been the type of day for whatever. I get a false that doesn't exist in the directory. So now you can write logic before you open to append a file. You could say file exists equals os.path exists. If file exists equal true, then open to append, else write file does not exist. So now you can start building your logic with these tools to check if something exists first, which may change what mode you open it in. If this file doesn't exist, well, write it because now it'll create the file. Else append. See where I'm going there? Now you can start to use this and build tools. And there's also other very important methods: is directory, is file, and list directory. Right. So if we do os.path.lister, Is it lister? Yeah, lister, open close. Oh, error. What happened? Everybody know? Is that real? What am I doing wrong? Is it os.lister? How do I get help on this? Anybody know? It's a built-in function called lister. So what if I do open close? Boom. So you don't need path there. It's literally it'll execute on the path where you're at. And you can also throw path in an argument for a lister. Yep, you got it. No, you got it. Good job. So this is helpful too because it gives you a list of all the objects in a directory, which then you could store in another variable and then do a find or look. So now you can write your own tools to find if something exists before you even write it or create it. I just want to show you that because it's freaking awesome, right? And this is where we're at putting this all together because creating data. I think this is just to write in files, and then we have the pickles and stuff. Um, Creating data is insanely powerful. Being able to work with data quickly at a fast scale via command line is insanely powerful. When you start using, like next week, I'm going to cover a couple other modules like URL lib, requests, and system. Now you could work with the internet and sessions and socket because now you could work with every layer of the OSI model. You could create sessions, um, call on web objects, use API keys, receive data from a web server, have it serve you data back, store it in a file locally, then work with that file. That's that's tool building, right? Now you're able to reach out through the network, extrapolate data, and generate a file type object, and then rip through it. So cool stuff, right? But this is lesson 7 in a nutshell. Any questions? No. Cool. I'm gonna go ahead and stop the recording, then I'll ask again because it's important.